Hello. Um, you're welcome to another episode of Maths Meets Easy by David Samuel. Okay, today on another fresh episode, we'll be dealing with highest common factor, highest common factor, which is also known as GCD. Highest common factor stands for highest common factor, yes. Sorry, GCD stands for greatest common divisor. Greatest common divisor. So as we all know, highest common factor is the largest number that can divide exactly two or more numbers without remainder. So that means if a large number can go into two or more numbers and without remainder, then it is termed to be called the highest common factor. So we've been treating methods, right? We've treated methods of solving highest common factor. So today I'm here with another method, an alternative method, a very simple method that can help us to deal with this HCF. All right. So quickly, let me get my board on. All right. So it will take a little time. Uh, and we're up. So just like I said, we are treating HCF. We call it highest common factor, or you can call it GCD, which is what? Your greatest common divisor. Now, just like I said before, we said GCD or HCF is the highest number that can divide exactly two or more numbers without remainder. Now, let's take, for example, we have this question, which is, okay, let's have this example. Let's start with a very simple number. Example 1. So you have this question. It says, find the HCF of 9 and 15. Now find the HCF of 9 and 15. Just as we said before, we have to look for the highest number that can divide 9 and divide 15 without remainder. So now let's see. We'll draw our table. We have solution. So we'll draw our table. We have 9. Then we have 15. Now, here, we have to look for a number that can divide 9 and divide 15 without remainder. A number that can go into 9 and 15 simultaneously. A number that can go into 15 simultaneously. So we'll start with the lowest prime, which is 2. So can 2 go into 9? Of course, 2 cannot go into 9. 2 can go into 9, but there will be remainder. It will be 4 remainder 1. So it is out of it. So let's check. Can 2 go into 15? Yes, 2 can go into 15, but there will be remainder. It will be 7 remainder 1. So let's move to the next prime number, which is 3. Now let's see. Can 3 go into 9? Yes, 3 can go into 9. Now, if 3 goes into 9, it will be 3 times. Okay, let's see whether the same 3 can go into 15. Okay, 3 can also go into 15. It will be 5 times. So therefore, 3 can go into 9 and 15. So now if 3 goes into 9, we'll have 3. And if it goes into 15, we'll have 5. So at this juncture, let's see, can any number go into both of them simultaneously? Okay, no number can go into both of them, both 9, 3, and 5 simultaneously. So here, since no number can go into both of them simultaneously, therefore, we'll say what? The HCF of 9 and 15 is 3. So that's your answer. The HCF of 9 and 15 is 3. Now, quickly, let's try other questions. Now we have number 2, which is find the HCF of 24 and 36. Now we should find the HCF of 24 and 36. So quickly, let's draw our table. Okay, so we have 24 and we have 36 as well. So we'll start with the trial and error method. Quickly, let's start from the lowest prime, which is 2. Can 2 go into 24? Yes, 2 can go into 24 without remainder. Can 2 go into 36? Yes, as well. 2 can go into 36 without remainder. So quickly, let's see. 2 goes into 24, we'll have 12. 2 goes into 36, we'll have 18. Again, let's look at it. Can the lowest prime, which is 2, go into 12? Yes, it can go without remainder. Can it go into 18? Yes, of course, it can go without remainder. Now, 2 goes into 12, we'll have 6 as well. And 2 goes into 18, we'll have 9. Now, let's see. Again, can 2 go into 6? Yes, 2 can go into 6. But can 2 go into 9? No, 2 cannot go into 9. There will be remainder. So therefore, we'll shift to the next prime. Now let's try 3. Can 3 go into 6? Yes, 3 can go into 6. Can 3 go into 9? Yes, 3 can go into 9. So quickly, we have 3 into 6, we have 2. Then 3 into 9, we have 3. Now we are down to 2 and 3. Now, can any prime number go into this pair of numbers, which is 2 and 3? Actually, they are the least prime numbers. So there's no number that can divide both of them simultaneously. So therefore, we'll end here. So we'll multiply the factors that we have here, the common factors. So therefore, we'll have what? HCF to be equal to 2 multiplied by 2 and multiplied by 3. So let's see. 2 multiplied by 2 gives us 4. 4 multiplied by 3, we have 12. So 12 is your answer. So I think this will have to stop here for now. So I believe this has proved to be helpful. So we have an alternative method of treating HCF. You can get the HCF between 2 or more numbers at exactly in less than 5 minutes, you're done. So We'll have to catch up with me next time, same station. Okay? Where we'll treat another topic. I still remain your tutor, your maths tutor, David Samuel. See you some other time. So bye for now. Bye bye.